Hello friends, today I'm going to explain L'Hopital's rule. Suppose f of a is equal to g of a, which is equal to 0, and f prime of a and g prime of a exist, and that g prime of a is not equal to 0. Then limit x approaches to a, f of x over g of x is equal to f prime of a over g prime of a. Let's see the proof of that thing. If you look at the proof, f prime of a over g prime of a, it equals to limit when x approaches to a, fx minus f of a over x minus a over g of x minus g of a over x minus a, which is equal to limit x approaches to a, f of x minus f of a over g of x minus g of a. Then limit x approaches to a, fx minus 0, gx minus 0, which basically give us limit x approaches to a, fx over gx, which proves f prime of a over g prime of a is equal to limit x approaches to a, fx over g of x. Let's look at the example. Okay, first one, limit x approaches to 0, sine of 4x over x. In this example, if we put 0 into the value, it gives 0 over 0, which is an indeterminate form. So we take the derivative of upper term and the bottom term, which gives us limit of x approaches to a, 5 cosine of 5x over 1. And now if we plug the 0 into the equation, it gives us 5. These are some indeterminate forms: 0 over 0, infinity over infinity, infinity into 0, infinity into infinity. Let's look at some more examples. Okay, in this, limit x approaches to pi by 2, 1 minus sine x over 1 plus cosine 2x. If we plug pi by 2 into the equation, it gives 0 over 0, which is an indeterminate form, so we have to use L'Hopital's rule. So in next step, limit x approaches to pi by 2, negative cosine of x over negative 2 sine of 2x. We are just taking the derivative of each terms. And again, if you plug the value pi by 2 into the equation, it's giving 0 over 0, which is an indeterminate form, so we will take the derivative again. So limit x approaches to pi by 2 gives sine of x over negative 4 cosine of 2x. And now if you plug in the value, it gives a value, which is 1 over 4. In the next example, limit x approaches to 1 from the positive side of 1 minus x minus 1 minus 1 over ln of x, which is basically limit of 1 from ln of x minus 1 over x minus 1 into ln of x. If you plug in 1 into the equation, it gives us 0 over 0, which is an indeterminate form, so we have to take the derivative, or we have to use L'Hopital's rule. So if we solve in the value, it basically gives us this thing: limit x approaches to 1 from positive, negative 1 over ln of x plus x over x plus 1. And now if we plug 1 into the equation, it gives us negative 1 over 2. Let's look at one more example. Limit x approaches to infinity of ln of 7x minus ln of x plus 2. From the logarithm properties, we can write down this equation as limit x approaches to infinity ln of 7x over x plus 2. And if we do the L'Hopital's rule and take the derivatives, it gives us, and also we can take out this logarithm outside of limit because it has nothing to do with the limit. So it's basically give us ln of limit x approaches to infinity of 7x over x plus 2. And if you take the derivative, it will be ln of limit x approaches to infinity 7 over 1, which is basically ln of 7. So that's about it about the L'Hopital's rule. Thank you.